Greetings, Patriots. In today's lesson, we are going to continue from yesterday's lesson as you looked at a vending machine as an example of a relation versus a function. And today we're going to, I want you all to set up your notebook, right? Look at your guided notes so that you know exactly kind of how to set your notebook up. So please take some time to look at your guided notes. Take your notebook, your math notebook out to set this up. Our objective today is that you're going to be able to identify whether a relation is a function or not a function by actually going back and using the definition of a function. You will also have the opportunity to write by justifying whether the relation is a function or not. So let's first just stop and go back and remember this word ordered pair. So as I think about the word ordered pair, okay, I know an ordered pair consists of an x-coordinate and a y-coordinate. And what we used to do with ordered pairs, right, is we used to plot these on a graph. And you've been using ordered pairs for a while, okay? So as I think about the first coordinate, it's an x value, right? That first number that you see is representing an x value. So I always like to highlight my x values in pink, okay? But in elementary, you knew your x values to mean your input values as well, okay? And your y values as your output values. Remember your input-output boxes? You also sometimes hear your x values being referred to as your independent variable, sometimes in science, right, as well, and your dependent variable. You also will begin to hear the words domain and range. And all of these mean the same thing. As we refer to our x values, we're referring to all the x values. They can be also called the domain. As we refer to your y values in your ordered pair, those are your range values. So I just want to make sure that you understand all of these words mean the same thing, okay? Let's go ahead and look at a relation. Yesterday we looked at a relation. We were talking about money and what we received from a vending machine, right? In order to get when we entered $1. So let's look at this set of ordered pairs because that's really and truly what a relation is. It's just a set of ordered pairs. So I'm going to highlight, if you have a pink highlighter, I like to highlight my x values in pink, just so that I keep my focus on that, okay? So your domain, once again, is your set, and I'm just gonna write, what is my domain? You'll hear me say this word over and over. Your domain consists of the set of all your x or input values. Now go and highlight your y values in yellow, 1, 3, -3, 4, and 1. Your range is going to be the set of all your y or your output values. And sometimes I may ask you, refer to the set of ordered pairs, right, the relation, and write all your domain values. So really what I'm referring to is the domain values that I highlighted in pink. So notice I have a -2, a -2, a 0, a 1, and a 3. Well, notice in my set notation here, I just listed the -2 one time. You don't have to write it twice, okay? So when you're listing all your elements, okay, when you're listing all the elements that represent your domain value, get rid of the duplicates, okay? Do not duplicate your values. Just write it one time, okay? And I also like to put them in order from least to greatest. And that goes for my range values as well. So -2, 0, 1, and 3 are all my input values. And my range values are written right here. These are all your y values. These are all the elements that you see up highlighted in yellow. -3, right? 1 and 3 and 4. I don't have to write the 1 twice. I know it's here twice, but I'm just going to write it one time from least to greatest. Okay, so again, a relation is a set of all ordered pairs. Make sure you write this in your guided notes. A little deeper to this word function. Okay, so what I did is I placed that definition for you right there. A function is a special relation, okay? And I always like to say this. It is a relation we know is a set of ordered pairs, but a function is a special relation. Okay, it's a special relation. Why? Because every single x value, oops, and I'm using my wrong color, every single x value is paired with only one y value. So let me go ahead and get my pink. Remember, I'm always going to focus on, oops, there it is. Every x value is going to be paired with one and only one y value. Only one y value. Our focus is our x. Okay, so let's take a set of ordered pairs. It doesn't matter what ordered pairs I take. Okay, so you're going to write this with me, or you can actually type it. I believe I did put some text boxes in the Google Slides. So let's say you have -3, +7. Write that down. I give you -1, +5. I give you 0, -2. And I give you 5, 9, and 5, and 3, okay? Here is your set of ordered pairs. Take your pink highlighter and only focus on your input values. So according to my definition, it says that every x is paired with one and only one y value. Well, we need to decide whether this relation, this set of ordered pairs, is a function or not according to the definition of a function. Well, if I look at these closely, if I look at the -3, the -1, the 0, the 5, and the 5, I can see that my input value of 5, right, has been paired not with one and only one y value, but with two values. So I'm going to have to say that this is a no, right? So this relation is not a function, and it's because of that element of 5. This relation is not a function. But tell me why it is not, right? Because our definition says x elements can be paired only one time. And I'm going to say, right, the x coordinate 5 is paired with more than one y value, is paired with a 9 and a 3. So therefore, it goes against, right, what the definition says. So this is an example of it not being a function. Now, I can represent a relation or a function in a set of ordered pairs, but I can also represent a set of ordered pairs in a table. So let's look at the following. -2, this is table A. I'm going to label this first table, table A. -2, 0, -1, -2, 0, 3, 4, -2, and 5, -3. Once again, with your pink highlighter, highlight your x coordinates only. When I'm looking to determine whether something is a function or not, I'm only going to focus on my x value. Well, if I look at my x values, first of all, I notice that they're all different, so that's a really good thing. So that means that every single element in my input values are paired only one time. This is awesome. So therefore, I'm going to say, decide whether this relation is a function. So if I'm only focused on table A, I'm going to say yes. Right? This is a function. So this is going to be a yes for table A. Why? Because every x coordinate, and I'm going to abbreviate coordinate, every x coordinate is paired with one y value. Use your function definition to help you justify with only one y value. Okay, let's go ahead and look at another possibility. All right, so the following x coordinates are 0, goes with 5. This is table B. 1 goes with 5. 2 goes with 5. 3 goes with 5. And 4 goes with 5. So go ahead and highlight your x coordinates. Once again, do I have a different x coordinate? I do, right? So every x coordinate is different. However, I noticed that what they share is the common y value. Well, guess what? That's okay, because here's table B. This relation is a function because each x is still paired with a common y value. And that's okay. They can share the same y value as long as they are different. Okay, Patriots, please don't forget to write. Every x coordinate is paired with a common y value, and when that's the case, that is okay, that I can pair it with a common y value because every x coordinate is still different. So it still meets the definition of each x value paired with one and only one y value? I can answer yes. So table A and table B, these are both considered functions. They meet the definition of a function, that special relationship. Okay? All right. So, again, you can see that I can represent a function using a table, an input-output table. Now let's go ahead and look at what a relation or a function might look like using a mapping diagrams. This is what you'll be doing in 8th grade math, right? So let's look at the following values. If I list -8 in this is my x values right here. So this is your domain values, all the elements of all your input values. -8, -1, 0, and 15. You can type those in your slides if you're using your slides. Then I have all of my range values, or my y values are going to be listed in the second map. And I'm going to have 2 range values, a 7 and a 9. Okay, so let's go ahead now and assign the input value of -8. If I look at the input value of -8, -8 is assigned to +7. There's one arrow. So again, if I look at the word function, my x value is being paired with one y value here. -1 is also paired with a y value of 9. So far, -8 and -1 are working correctly according to the definition of a function. Let me go ahead and go to 0. 0 is a different element, right, in x in our domain, and that is assigned to y. And that's okay as well because it's an x coordinate of 0, so it can share the common y value of 9 with -1 because it's different. Now 15, when I look at 15, 15 is assigned, I see, to 7, but it's also assigned to 9. So 15 actually has 2 y values. So it has 2 arrows coming from it. As soon as you see that your x value of 15 has 2 arrows, that means it is paired with more than one y value. So can this relation be considered a function? Well, I'm going to have to say, according to the definition, I have to say, no, it is not a function. So why my range values are not a function of x? Because x has 2 assigned y values from 15, okay? 2 arrows are pointing at that. So let's go ahead and write that down. Write why it is not, okay? It's not a function because 15 right, is assigned, right, or 15, I'm gonna simplify it. 15 has 2 arrows, right? And it's assigned 2 arrows. Oops. It is assigned the y values of 7 and 9. And that, right, violates the definition of a function. Okay? So this is not a function because 15 has been paired. 15 is paired with more than one y value. More than one y value. I just want to make sure that you're understanding why. Go back to the definition. Because there's 2 arrows, right? That means 15 has been assigned to 7 and 9, and therefore it makes it not a function. Okay, let's go ahead and look at our final representation of a relation or a function. So we can also graph it. We have built it from an ordered pair. We've looked at relations and functions in a table and in a mapping diagram. And now our final representation is going to be a graph. I can take a list of ordered pairs like you guys are used to. And in fact, I'm going to go ahead and highlight my, my x axis here, right, with my pink. My x-axis has been in pink, right? And my y-axis is in yellow. Just like to keep my color coordinated. And I'm going to go ahead and graph the table values above. The table values for my input-output table of 0, 5, 1, 5, 2, 5, 3, 5, etc. The ones from above, just to show you how a function can look like on a graph. So I know where x and y meet is 0. So 0, 1, 2, 3, 4, 5. 0, 5, that's the ordered pair there. 1, 5, it's right there. 2, 5 is there. 3, 5 is there. And 4, 5. So as best as I could, I tried to plot my points, right? So again, is every x value assigned one y value? I'm going to say yes, right? I'm going to put this relation is a function because every x coordinate, every input value is assigned a single y value. And it's okay that they share the common y value because it still meets the definition of a function. Now, we're going to do one more test that you guys can do whenever given a graph. If I take a vertical line, it's the way we walk, not the way we sleep. If I take a vertical line and I draw it through that point, right, through the point 4, 5, it only intersects at one point. If I take it through the point 1, 5, it only intersects at one point. And so forth. 0, 5, it only intersects at one point. So when your vertical line intersects at one point, when it intersects at one point, the relation is a function, okay? So I'm going to write that down. The relation is a function. It meets the definition of a function, okay? The vertical line test, if it intersects only one time, it is called a function. So I know this was quite a bit of notes in today's lesson, but you're going to hear this vocabulary throughout the week, and I want to make sure that you understand the difference between a relation and a function. So as you can see from these notes, this is a good set of notes to place in your math notebook so that you can reference it through this unit that we're going to be studying. So we were able today to see how a relation can be looked at in a set of ordered pairs, an input-output table, a mapping diagram, and a graph. I want you to think about, well, what is one characteristic of a function, right, that you observed, or not a function, something that's not a function that you observed either in a set of ordered pairs, in a table, in a map, right, mapping diagram, or in a graph. What is something that you noticed of what a function was versus not a function? So you may have to answer that question with your teacher tomorrow or in a discussion question in Schoology. Have a wonderful day, Patriots.